2022 marks the 50th birthday of NASA's Landsat program. NASA Harvest has taken this occasion to discuss the intertwined history of Landsat and agriculture with individuals who have been involved with the program since its early days, and explore how the Landsat program might continue to impact agriculture over the next 50 years.
I feel like Landsat's superpower is time travel. And I feel like it's impacted so many fields, but definitely in agriculture. Utilizing that time series of Landsat allows us to find change, see where croplands are expanding or contracting, where other land cover types are converting to agriculture, and look at crop types and agricultural or crop health.
There's a very much intertwined history between Landsat and agricultural applications. In fact, the major catalyst for the very first Landsat mission was something known as the Great Grain Robbery. In the early 70s, there was a worldwide shortage of wheat, most everywhere but the US, but we didn't really know. We had no way of monitoring, we being the US government. And so the Soviet Union bought a whole lot of our wheat surplus at a very low price. And then there was a shortage and prices went crazy.
This event coincided with the launch of Earth Resource Technology Satellite 1, providing a clear mandate for some of the first experiments to focus on developing capacity to monitor global agriculture.
Landsat and agriculture go hand in hand because agriculture crops are a seasonal phenomenon, and you really need to monitor it closely over time. Been able to monitor the seasonal green up, the peak greenness, and then the fall senescence and harvest. And not only that, but we can monitor the irrigation of agricultural crops. We can monitor damage from floods or severe hailstorms. So the repetitive coverage is quite unique. That and the multispectral aspect, it lets you determine something about the overall vigor of the crop and let you do more precise crop yield estimates well in advance of the final harvest.
I think that the Landsat program relative to agricultural monitoring has been profound. The whole idea that Landsat could look at the condition of crops, the acreage of crops, seeing how they evolve, diseases, whatever. It just has been tremendously impactful for agriculture. Out of all the applications, other than maybe just monitoring land use and land change, I think agriculture has been the area that has benefited most and utilized most the Landsat series.
I served on the Federal Advisory Committee for the National Archive at EROS. Daryl and I both did, actually. And at one point, we were advised that only about 2% of the National Landsat Data Archive had ever been looked at. And you can imagine my reaction, which was not very positive.
In 2008, under the USGS Imagery for Everyone program, spearheaded by Barb Ryan, then the Associate Director for Geography at USGS, Landsat data at last became freely and openly available to all.
The really critical part of that has to do with taking the cost to the user away so that then they can put all of the funds they have into mass processing and analysis of the data. It's very critical. And we went from people maybe were looking at only 10,000 scenes a year to well over 1 million scenes a year in less than a decade. I mean, it was a huge, huge shift. That decision to free the archive released the potential of the mission that existed from day one, but had never been realized until that decision was made.
Since the Landsat archive was made freely and openly available under that USGS Imagery for Everyone program, we've seen an explosion of applications of the data, from providing early background maps for Google Earth and Google Maps to supporting operational generation of official agricultural statistics.
The National Agricultural Statistics Service, NASS, we're primarily a survey agency. We have boots on the ground, and we interact a lot with farmers and ranchers to gather statistics on all facets of U.S. agriculture. So the NASS Cropland Data Layer, it's kind of our flagship geospatial product within the agency, is our best effort at mapping the nation's crops every year annually at 30-meter resolution. Not coincidentally, same as Landsat, and Landsat has been the core of that product in terms of Earth observation data. Prior to 2008, when Landsat data was not free, it was a pretty limited and really just a research project. Could we map accurately, maybe rice in some small corner of Arkansas or wheat in North Dakota? When the Landsat archive became freely available, that really expanded our ability to try to incorporate all that data across the United States to create what now is a sea to sea, ocean to ocean, 30-meter land cover product that we produce annually.
That we have been tremendously impressed by the almost explosion in technology and the science of remote sensing, particularly with Landsat, in the last 10, 15 years. We're doing things today almost routinely that many of us only dreamed about 30, 40 years ago. And that's great, that the advancements that have been made. And, looking forward to Landsat Next, I think that'll be great. Another big step forward. It's going to, I think, be truly excellent. I look forward to seeing continued advancements that will increase the applications of value to agriculture and society of Landsat data.
I think we're in a pretty amazing time right now. I've been in this field for over 30 years, and there are so many things going on, it's sort of impossible to narrow in on just one. I'm particularly a fan of time with phenology, vegetation phenology, and drought impacts. The time dimension is extremely important, and more frequent data allows for higher accuracy and better characterization of agricultural phenomenon.
As we move forward, I think we are entering a sort of golden era for agriculture, and not just across the U.S. Because Landsat's a global system, the imagery it's equitable, right? It's not just being collected over Iowa; it's being collected everywhere. But the areas which have really lacked in data, it's global, whether it be in South America or in the equatorial areas. Those areas we have much less statistical information, much less robust on-the-ground information. So remote sensing from Earth observation, particularly with Landsat, I think we're finally going to get the rest of the globe caught up to what we're doing here at NASS and domestically within the United States.
As we look ahead toward the next 50 years, we're facing substantial global challenges, and agriculture has a huge job to do to simultaneously continue to increase production while supporting land, water, atmosphere, and human health, and while continuing to provide livelihoods for 1 billion people and sustenance for 7 billion people and growing. There is a role for satellite remote sensing to play in both providing timely, synoptic, objective, and repeatable information about agriculture, as well as in supporting on-farm decisions that can help agriculture meet this grand challenge. With 50 years of experience in our pockets, thanks to the Landsat program, NASA Harvest and its partners around the world are continuing to address threats to food security and agricultural sustainability worldwide.